All right, so today we're going to look at finding the derivative of polynomial or polynomial type functions and, of course, some trig. Guys, what do I mean by polynomial type? Any ideas what I might mean by that?
No.
None whatsoever? What's a polynomial?
A shape.
Not really. That's a polygon. Close. No ideas? X squared plus 2x plus 4, something like that, right? Trinomials, binomials, etc. Okay? You did a whole bunch of them. Usually you guys had to factor them. I've made you do this. Okay, that's a polynomial. The key about a polynomial is that all of the exponents are whole numbers, meaning they are from 0 to infinity. No decimals. Okay? The difference is that polynomial type means I can include negative ones. I can also include like fractional or things like that. Okay? That's why in our pre-calc unit I had you review that stuff, because then we're going to be able to use it so that we can make things a little bit easier. And that kind of begins today. So, first things first is, of course, the bell work, which you clearly all did since you were all talking. So, who can help me with that bell work there? Of these two pictures here, which one of those is f of x and which one is the derivative of f prime, and why? Don't look at it that crazy. It's actually real easy.
So the original is the first one, and the derivative is the second.
Absolutely. How come?
Because it literally touches, like if you put on the same graph, it touches the other ones.
Okay, so you're saying like this is like a tangent line.
Yeah.
Could be. That's not quite what's going on here, but I see your thinking and I like it. It's very similar. Guys, what's the degree of the first one? Ah, sorry, she said it the other way around, didn't she? I wrote that backwards. That should be f prime. Sorry, Marta. What's the degree of that first one, f of x? It's not a trick question, guys. It's quadratic. What's the degree? Huh?
Squared.
Squared, right? 2, right? Quadratic. That's what gives us the U shape. What's the degree of the f prime? Not a trick question, Martine.
Martine.
I love how he's surprised every time I say his name. Don't ask why.
What?
Why?
Why what?
Well, what's the degree of the second one?
1.
1. So why is that the derivative automatically? Think about last class, guys. I made you write it down. The derivative was always 1 degree less, guys. It was always 1 degree less. All right? Because if the derivative is all your slopes, then this is simply an indication of all the slopes around this curve. Okay? So our reasoning then is just that f prime of x is 1 degree less than f of x, which is what we talked about last class, right? Hence why I'm doing this now, right? The whole point is to always review the previous question or the previous lesson in our bell work. All right, who feels like they can tackle the second one?
Me.
Good, what is it? Which one's g, which one's g prime?
G prime is the first one.
Good, absolutely. This is g prime. Why is that? Well, if g prime is all the slopes, what's the slope from negative infinity to 0? What's this slope? Not a trick question. Just go back to pre-calc, even like grade 7.
1.
Close. Negative 1. Negative 1, right? 'Cause it's going down. And this one is positive 1 because it's going up, right? So if we look here, hey, look, that's exactly what this graph shows, right? Negative 1, 1. What do you notice is going on at 0? There's a hole. It's not defined at all, which would mean that there's no derivative. There's no slope. I want you to think about this point here. Why would there be no slope there? Is that what's going on? Nico, what do you think, man? If you look at this point right here, the girls are telling you obviously not.
No.
Guys, there's an infinite number of slopes. That's what's going on. So I call it like a hard corner, a cusp, something like that. Basically what it means is like this is a tangent line, this is a tangent line, that's a tangent line, that's a tangent line. I can draw an infinite number of tangent lines. Therefore, there is no tangent line, right? Because there's too many of them, which is when we say it's undefined. And guess what it means when there's no graph? Undefined, right? So that's the reason that it doesn't exist at 0. All right. let's actually get into the lesson today proper. So we're going to consider the function f of x equals 3. What does the graph of this function look like? So let's start right there. F of x equals 3. That's the same as y equals 3. What does that graph look like? Lucas. Yeah, you, buddy. Yeah, the other one's not here today. It's all you. What does a graph of y equals 3 look like? You don't know. Close. That's x equals. Okay? So y equals is going to be horizontal. So it's going to look like this. Okay? Now, if a tangent line were drawn to that, what would the slope of that be?
0.
0, right? The rise, the vertical component is 0. So therefore, the slope equals 0. So based on that process, f of x equals c, where c is a constant, then the derivative is what? 0. Look at this. Girls paying attention already. All right, perfect. So then what we're going to do here is I want you guys to put down your pencils. It's really important that you put them down right now. Seriously, okay? Put them down, and I want you guys to just watch. Just watch what I'm doing and see if you can figure out what I'm doing to find the derivative so that you don't have to use this definition anymore, right? Because I'm pretty sure most of you don't like that definition. I don't like that definition, right? The limit as h approaches 0 of f of x plus h minus f of x. It sucks. It's long. It's hard. It's annoying. Every time you guys do it, you guys are like, this sucks. So let's see if we can figure out another way to do it. Just watch and see if you can figure it out. Because by the end of this class, the hope is that you guys can do it the same way I'm doing it right now. Anybody think they got it yet?
No.
Okay, now we're going to get into where they are not whole numbers. Nico, drop your pen, man. The whole point is I want you to just try and figure this out. See if you can come up with how I'm doing it. Is it? Perfect. Okay, that's part of it. I'm absolutely... There is something... No, the whole point is to see if you guys can figure it out. Luciana got half of it. I am multiplying something for sure. There you go. Okay. So the number of the exponent is being multiplied by the coefficients. Absolutely. That's part 1. What's part 2? Right? So if we look at, let's look at some of the easier ones up here, right? They're absolutely correct. The 2 came down and I got 6. Right? The 1 came down and I left it as -2. The nothing or 0 came down and made it 0. What's... kind of. I didn't necessarily take... I took it out in one case, not every case. So what is going on with that exponent, guys? I brought it down. What's the second part? There you go. Exactly. So this 2 came down and became 6, and the 2 that was there became 1. The 1 that was here came down and left it as -2, and then that 1 became 0. What's anything to the power of 0? Not quite. 1. So that's why the x disappeared, Luciana. And then here, this is technically like saying x to the power of 0, right? Well,
Yes, sir.
that means the 0 comes down. Anything times 0 is 0, it goes away. Or the derivative of the constant, which we already talked about, is just 0, right? Okay, Maxo, what's up?
I missed why you removed the x of 2 numbers.
This one?
Yeah.
So what I did is think about it as like this is a 1, right?
Yes.
The 1 comes down, and I'm left with -2x to the power of 0 because Tomas said we had to subtract 1.
Yeah.
What's x to the power of 0?
0.
Not quite. 1. So the x goes away. That's the point. Raquel.
For example, in the second one, after doing like -5 times 3, why does it stay -15 to the power?
So because here, the x cubed, I subtract 1 and it becomes x squared.
You only need to subtract.
Exactly. So if we look like at another example here, right, the 6x to the 4th, the 6 came down, became 24, x to the cubed, right? Because 4 minus 1 gave me 3. And when I ended up doing negative ones, it was no different, right? The -1 came down, -2 times -1 is +2. Negative 1 minus 1 is negative 2. So do you see how that's working? When I had a fraction, it was exactly the same thing, right? 6x to the 2/3. 6 times 2/3, maybe a little bit harder to do in your head, but 6 times 2 is 12, divided by 3 is 4. There's my coefficient. 2/3 minus 1, again, a little bit tricky, but negative 1/3. Does that make sense? All right, guys, I'll give you a second. I want you guys to copy those down, okay? So you can pick up your pencils again. All right, so let's write this in a general form, okay? So if we're looking at this, this is called the power rule of differentiation, which means d over dx, this thing here, this, guys, simply means derivative. So it's just another way to write the derivative, right? It's the same as saying f prime of x. We say d over dx. Okay, I'm going to throw a couple of different ways at you guys so that you are familiar with it.
So
Huh?
d over dx is f prime of x.
So hang on, let me get there. Right now I'm just explaining the d over dx. So that just means derivative. X to the power of n just means x to the power of anything. And what happens is it's going to be n times x to the power of n minus 1, right? That derivative comes down, and then we subtract 1 from the exponent to get our new exponent. That's all it was for power rule. Make sense? Yeah, we feel good about it?
That's the written thing of what you just explained on the
Yep, exactly. This is like a general term for it.
Okay.
I don't think I have a poster for it because this one's so simple. But if you want one, you guys can make one and put it up. That was interesting. All right. You guys know that, no, never mind. No. In order for, no. Wow, it's very forceful. Later. In order to apply the power rule of differentiation, the equation must be written in polynomial form, and I just told you, what does that mean, polynomial form? Okay, good. So it means like a polynomial, but with rational exponents. No, it cannot. Rational means fractions. It means fractions, negatives, everything. It just means that it needs to look kind of like a polynomial. But the exponent can be whatever we want. Because officially a polynomial has to have like 0, 1, 2, 3, 4, 5, etc. Okay? Awesome. So if we, actually I'll give you another second to write that down. Finish writing it down. Plus that means I can update the attendance since somebody came in late. Emiliano. Where were you, buddy? Where were you? All right. Okay, so if we take a look at these next examples here, what's the problem with them? What do they not look like?
I know.
They don't look like something I just said we need, guys. What do we need? Yeah. These don't look like they have them yet. They don't look like a polynomial. So what we're going to do is rewrite the question first. So f of x can be rewritten in this form. Do you guys agree that that is exactly the same as what's written there?
Wait, that's what you did before.
Yes, miss.
Yeah. Because all I did is I took the over x squared and made it x to the negative 2, right? And remember, cross the line, flip the sign of the exponent, right? So it's the same thing.
Why is that?
Didn't change anything. Just wrote it differently. Why would that be helpful?
Why is
Don't know?
that prime?
Well, because now when I take the derivative, it's a whole lot easier to do, right? What happens to that negative 2? Do I want to know what you're looking on that camera?
It becomes negative 4.
Negative 4, perfect. X to the
And negative 12.
not 12, no. Negative 2 minus 1 would be
Negative 3.
negative 3. There we go.
And then negative 12
There you go.
over the x to the.
Perfect. She's got it already. Look at that. Look at that. I know. You know why? It's because she keeps coming and hanging out in Calculus BC. She's joined our BC class sometimes. I don't know what class she's supposed to be in, but she shows up here. Okay, that's why. All right. So,
Hate someone in that school.
do I hate? Yeah, of course. Can't say, man. Can't tell you. can I rewrite that question? All right, so how do I rewrite that? If everything's over x, can I just reduce
Add
the
x.
degree? Not add it. It's dividing by x, so can't I just... Well, I even easier than that, I can literally, I can just divide everything by x, right? So it's going to be 3x cubed minus 3x minus 2. Would you agree that that's just a simplified form?
Yes.
Right, all I did is take out an x of everything. Good. All right. Carolina, what is the derivative then?
9x
Perfect.
squared
Yeah.
minus 3.
Yeah, exactly. Because there's a 1 there, right? And that's it. Everything else just goes away for us. How nice. All right, now this next one is probably going to be a little bit more complicated for us to try and rewrite. So let's do it in steps. The first thing I'm going to do is I'm going to write this with fractional exponents. So 3x over x to the 2/3, right? Because the cubed root is the same as an exponent of 1/3. But then I can rewrite that as well. Because how do I like simplify these x's here? Yeah, how? Exactly, in the very first year, right? Like, and in the first one even. So I could do x to the negative 2/3, but it's kind of like an extra step. Really, I just need, because then I would add them. If they're already divided, ladies, can you do that later? It's just very distracting. So it'd be x to the power of 1 minus 2/3. You guys remember that from pre-calc? Right? Algebra 1. So this would be 3 to the x to the 1 minus 2/3, which is really 3 to the negative, oh, sorry, not negative, positive. 3x to the positive 1/3. I'll write it again down here so there's more room. So 3x to the 1/3. Does that make sense how I got there? 1 minus 2/3, yeah? I know, so stressful. All right, now that I've got that, I can do the derivative. Martin, you can do it, buddy. What's the derivative? Bring down the 1/3. What's 3 times a third?
1, 6, 1, 9. I know.
1.
Just 1, buddy. Yeah, it's okay. And then what's 1/3 minus 1? Can you do that in your head? That is a tougher one. 1/3 minus 1, that's the same as 1/3 minus 3/3. What would that be? What's 1 minus 3? Negative 2 over 3. That's all right, that's all right. Does that make sense to you guys? So sometimes you need to do a little bit of algebra to make it look like a polynomial, and then you can usually simplify it very quickly to find the derivative. Okay? This next one, do I need to rewrite it?
No.
No, it's already in a polynomial form. We just got to actually take the derivative. The hard part is that now we've got to do that with a bunch of fractions. So negative 4 times 3/4. Who can do that one? Negative 3, exactly. Now probably the trickier part, 3/4 minus 1. Negative 1/4. Perfect. All right. 2 times a quarter. Yes, you can. Yeah, I'll let you use a calculator. That's fine. What's 2 times a quarter? Uh-huh. 1/4 minus 1. Negative 3/4. Is that making sense to everybody? Okay, so you can use a calculator if you need to, but like that's all we're going to do. All right. Now, for this one, what we're going to do is I just need you guys to memorize these two. They are written on my wall over there, I think behind Maxo as well. Although you may not be able to see them because of Andres and Matia's giant poster, so we may have to move their poster. But basically, the derivative of sine, what I want you guys to know is that it's cosine of x. And therefore, the derivative of cosine is, you might think sine, and you'd be really close, it's negative sine of x. So you're going to need to memorize those two. Honestly, guys, it's probably going to happen just from doing the problems. If you just do the practice, you're going to like have that memorized by the end of the week. Okay? Because they're going to come up lots. And if not, they're written on the wall back there behind Maxwell. Okay? So you can always look. All right. So now when I look at something like this, right, the issue is I've got a whole bunch of stuff multiplied together. I can't actually, like, it doesn't look like a polynomial. So I need to first make it look like a polynomial. So I'm going to have to do a bunch of work here to rewrite this equation. So what I'm going to do is I'm going to deal with this part first, because we've done them lots and we remember how to do perfect squares because we're all smart, allegedly. No, we're all smart. All right, so x squared plus 2 times the middle term of x plus the last term squared. Is that ringing a little bit of a bell to you guys? You remember that? We've done that lots this year and previously. Yes? No? It's too early in the morning? Exactly. I made you do lots of x plus h squared. All right. Now the part that's arguably a little bit trickier, because I can't just use the simple FOIL acronym, is that I got to take 2x and I got to multiply 2x into everything, and then I need to multiply -1 into everything. So let's start with the 2x. So 2x into everything becomes 2x cubed. 2x times 2x is 4x squared. 2x times 1 is 2x. All I've done is taken 2x and multiplied it into every term of the trinomial. Does that make sense? Yeah? Now the easy part is -1 times everything. Well, that just means I'm flipping the sign. So minus x squared minus 2x minus 1. Real easy when you multiply by 1 or -1. Now I need to collect my like terms. Is there anything that I can put together there? 2x cubed is by itself. What else? What one? Yep. Yeah, the squareds, right? So if I put those together, I'm going to get 3x squared. What else can I put together, guys? How about the x's? What happens to 2x and -2x? Just gone. Just gone. And so then it's -1. So that's my function. So now I need to find the derivative. Okay. So I bring down that 3, it becomes 6x squared plus 6x. Now, Jose, go back and read the very top part there. What does it say?
When x equals
Exactly. So what we need to do now is we need to find our pot and sot. So remember, the pot is going to be -1 and then plug -1 into this original equation. If I do that, it's real easy. What's -1 plus 1? 0. 0 squared is 0. Anything times 0 is 0. Perfect. The y value is 0. Okay? All I did is hold on, man, hold on. All I did is I did f of -1, which is 0. Why? Because it's 2 times -1 minus 1 times -1 plus 1 squared. And since this is 0, everything else is 0. As soon as you multiply by 0, it's all 0. Okay? So that's why I got the point -1, 0. All right, now, then I need to find f prime of 1 for my sot. So I'm just going to plug -1 into here. -1 squared is? -1 squared. It's okay, it's okay. -1 squared. Positive 1 or -1? Positive 1, good. So that gives me 6. 6 times -1 is? -6. What's 6 minus 6? So my slope is 0. So therefore, if I write my equation of a tangent line, which if you remember is this, equals mx minus x1. So that means it's going to be y minus 0, don't need to write that, equals 0 the slope. If the slope is 0, do I need to write any of the x stuff? Nope, that's literally the equation of my tangent line. Easy, right? Allegedly. All right, next one's a little bit trickier. You're going to have to remember the unit circle. Thank God it's drawn on my wall. All right. So, first thing I need to do is find the derivative. So, if I find the derivative of this, what did I say the derivative of sine was? We just wrote it down? Cosine. Just positive cosine. There we go. So, cosine theta. Now, what's the derivative of theta? That might be tricky, but think about what is the derivative of x? 1. Exactly. So, in this case, -1. Exactly. Right? Good. That's it. Then I need to find my pot and sot. So my pot is going to be pi over 2. And I need to plug pi over 2 into this. What is sine of pi over 2, guys? If I find f of pi over 2, that's going to be 4 sine of pi over 2 minus pi over 2. What's sine of pi over 2? What is sine of pi over 2? Look at the unit circle on the wall. Always forget that Matas needs glasses. She needs glasses, but she won't wear them. Maybe you need to get new ones. 1, exactly, it's 1. So this is literally going to simplify to 4 minus pi over 2. Now I could write that as a funny decimal, or I could just leave it. Let's just leave it for now. Right, no need, but if you want to, you can turn it into a decimal. All right, now I need my sot, which means that I'm finding f prime of pi over 2. Now this one's a little bit easier because it's up here. What's cosine of pi over 2, guys? It is. You're doing the derivative there, buddy. All right, so cosine of pi over 2 minus 1. This whole thing is 0, so it just becomes minus 1. So that's my slope. All right, let's see if we can write this now. Y minus y1. What's y1? What is the y coordinate of my pot?
4 minus 1.
Yeah, it's kind of ugly, but it is just 4 minus pi over 2, so let's leave it like that. Equals the slope, that's easy, -1, times x minus the x coordinate. What's the x coordinate? No, look up at the pot. Pi over 2, right? That's why we write them down as pot and sot, because it helps us do this part easier. There you go, done. Nope. No, usually I'm not going to make you simplify it. You can just leave your line like that. And there, you'll see like in the next unit why, or even later in this unit, because it's easier if we leave it this way. Okay, so, oh, sorry, my bad. I'll wait. All right. There we go. Given the equation of a function, how might you determine the values at which the function has a horizontal tangent? So, in other words, when does f prime of x, what does it need to be equal to have a horizontal tangent? Well, horizontal tangent means a slope of what?
0.
Exactly. Which would mean the derivative is simply just 0. That's all. Right? Our reasoning, rise equals 0 for a horizontal line. Amazing. All right, so let's do 2 more of these. At what value of x will this function have a horizontal tangent? So what does that mean? That means first find the derivative, and then once we find it, make it equal to 0. So it's kind of like what you did when you were factoring in pre-calc, right? All right, so we're going to find the derivative first. 3x squared plus 1. Why? Because the 3 comes down, subtract 1 to get 3x squared. The 1 here comes down, and then we subtract 1 and it becomes x to the 0, which just goes away. Okay? So I'm just using that new power rule we did. And then I'm going to make it equal to 0. So 0 equals 3x squared plus 1. And then I just start solving for x, right? Minus 1, going back to like middle school algebra here. What's my next step of middle school algebra? Divide by? Awesome. So I got -1/3 equals x squared. What's my next step? Yeah, square root. All right, what's the problem? I can't do the square root of a negative. Therefore, what do you think that might mean? Exactly. So f of x never. All right. So f of x will never have a horizontal tangent, at least based on our understanding so far. It actually can still have one. All right, now let's try trig one, because we love trig. Yeah, we do. All right, at what values of theta will this function have a horizontal tangent? Well, the process is the same, right? So find f prime of theta. We already said the derivative of theta was just 1. What's the derivative of sine? Cosine, exactly. Then we got to make it equal to 0. Go through it. Who was it? Maxwell, go pick it up, buddy. All right. I don't know. Then let's do our middle school algebra. So -1 equals cosine of theta. Now you should be able to just look at the unit circle now and tell me what's theta. If you can't, you could do the arc cosine. When does cosine equal -1, guys? Look at the unit circle. You got it right, pi. So theta equals pi. Now it says to find all of them between 0 and 2 pi. Is there any other times that it would be -1? If you look at the unit circle, can it ever be -1 again? No, right? Like I'd need to add 2 pi and then it'd be 3 pi, which is outside, or 5 pi, etc. So this is the only time. So theta equals pi. This is a horizontal tangent. Now, if you couldn't do it on the unit circle, guys, really quick aside here is that you could do cos inverse of -1 is equal to cos inverse of cosine of theta. And of course, those cancel.
When we look at cos, we always look at x values.
Exactly. Cosine of theta is always the x. Think of it as x on the unit circle. Yep, exactly.